Mathematics. This is Ron Martiello, and welcome to Things That Rock. These are lessons that have been student tested and teacher approved. And recently, I did this time elapsed problem lesson in third grade, and I'm very excited about it. I utilized some Jamboard. I also utilized Pear Deck, but I'm going to use Jamboard for this presentation right here. So there are a couple things that I want to kind of talk about with elapsed time. There's like the approach to time elapsed problems, and then there's also the procedure that kind of goes along with that. That's where the numbers do the work. We're going to be talking about two different things here, but they both are working together. And so when we present students with a time elapsed problem, we want to make sure that they have a great approach as well as the procedural skills to solve the problem. Let's get started. First of all, I want to talk a little bit about the approach. And that approach is very important, especially in relationship to solving problems in the situation. Believe it or not, this time elapsed problem, or most time elapsed problems, are add to take away problems that kids learned in first grade. Like those problems where there are 5 cookies on the plate and 2 were eaten. There was a change. And then at the end, there were 3 cookies. Or maybe there were 10 birds in a tree and 5 flew into the tree. And then there were 15 birds at the end of the story. Those are add to take away problems. And those add to take away problems have a start number. They have a change number that either is added or subtracted. And there's a finish or a result. In a real add to take away problem or a traditional add to take away problem, the last number is usually the result. But because this is time elapsed type of problems, these are time elapsed type of problems, we're going to use the word finish so we don't confuse the students. We want them to talk about the finish time. So there's a start time, a change time, and a finish time. Let's get started. Our first problem, we have a situation where you woke up at 6:45 a.m. You are done breakfast by 7:05. How long did it take you to eat breakfast? When we present this to our students and we're looking at the approach and trying to find an entry point into the problem, we don't want to go right to our procedure. You see, we want students to understand, like, what are they solving for? What's the unknown? The unknown could be the start number. It could be the change number, or it could be the finish. We ask students about, what does the problem give us? Does it give us a start time? Does it give us a finish time? Is there a change in the problem? This problem, we obviously are looking for a change. We're looking for the change because we're looking for the change between 6:45 a.m. and 7:05 a.m. So we're given a start number, we're given a finish number, we have to determine the change. This is really important for students to have a conversation about, especially when they're analyzing these types of problems. Lots of students are going to want to take 2 numbers, add them, subtract them, and try to find a finish, but that's not what this problem is asking us. So let's go into the procedure. I like using a timeline because clocks get a little wonky. Kids have a hard time going from 1 hour to the next hour. And a number line is much cleaner. And again, we can really illustrate, and the students can really illustrate where the start time is, where the finish time is, and they're able to see what the numbers do in between those times. In this problem, we have a start time, which is 6:45. And then we have a finish time, which is 7:05. Our grown-up brain knows that's 20 minutes, but we may have students identify it with an N. An N is a great way to represent an unknown number and make sure that students understand what position they're solving for, even if we're working procedurally here. I'm going to erase that right now. I'm going to write in the 20 minutes here. But you know what? I may not like to do it this way. I might want to count by 5s. I might want to count by 10s. I might want to find a friendly number. So I like the friendly number piece but there are lots of different ways to get it. 7 o'clock. And I know that from 6:45 to 7 o'clock, I add 15 minutes. And then from 7 o'clock to 7:05, I add 5 more minutes. And then I know both of those together equal the full 20. Again, that's the way my brain saw it. Your brain may have seen it differently. This is that opportunity for students to find their own pathway through the problem. The entry point is through what situation am I in, add to take away, what position am I solving for, start number, the change number, or the finish, and then let's try a solution attempt and utilize the number line. And this is where they have some freedom and some creativity to be able to show you how their brain is solving this problem. Let's go to the next one, because maybe we're not solving for the change. Maybe we're solving for something else. You wake up at 6:45 a.m. It takes you 25 minutes to get ready for your game. What is the earliest time you can leave for your game? I've been in this situation, coach my kids in sports all over the place, trying to get them in the car. Totally get it. Maybe your kids can relate to that. Your students can relate to that because they're on the other side of it, getting ready for their game. But what are we solving for here? Okay, what's my entry point into the problem? I'm going to ask the students, hey, tell me this problem in your own words. Tell it to me. Don't read it. Tell me in your own words what's going on. Then they tell you, and it's like, now we start trying to make sense of it. We figure out the situation. This is an add to, take away type of problem. There's going to be a change. We have a start number, a change number, and a finish. Find the start number in the problem. Do we have a change number in the problem? What's the unknown? It's the finish. That language, again, very important. We want to make sure that we're consistent in these types of problems. Again, we have our number line. We ask them about the start number and the change number because they've identified that the start number is 6:45, the change is 25 minutes. We go here to our number line, 6:45. We know that there's a finish time. We don't know what it is. It's unknown. And now we have a jump. And how long and that jump is like, that's our change number. What was our change number? Our change number was plus 25 because I'm going from my start to my finish, which I don't know yet. And again, students can find many ways to solve this. Maybe they do the one jump of 25. Maybe they do increments of 5. Maybe they do increments of 10 and a 5. Maybe they find that friendly time or that friendly number in between. Let them have at it, and also share their ideas with one another because they need to see how there are different ways to get to this solution, multiple pathways to that solution. Finally, they may be presented with this problem, and we're not trying to find the finish and we're not trying to find the change. We're trying to find the start number. You woke up this morning for your game. It took you 15 minutes to eat breakfast. It took 20 minutes to get dressed and get ready. You left your house at 8:30 a.m. What time did you wake up? Now, I have 2 change numbers in here, and that's something that you're going to want to discuss with them because they're going to think that 15 minutes is like your start number because they're thinking procedurally through this and not conceptually. Talk about how that change number is 2 numbers combined, and that the finish nut seems as though they got the finish number there. Why is that the finish number? What is the unknown in the problem? Is it the start number? Oh, it's the start number. Again, you go to your number line and everything works out. They have an unknown start. We can mark that as N. They have 2 jumps, and then they get to their finish. Their first jump is plus 15, or maybe it's minus 15 because we have the finish. That's right. We have to go with the change. So I'm going to erase that. And that's okay. I changed my thinking. I need to celebrate that. I made a mistake. I changed my thinking. I come in here. I go, oh, I got to start from the end. This is minus 20. And this is minus 15. I know I messed up. That 20 is a lot bigger than the 15. But the point is, they need to now work backwards from their finish to find the start number. And now the situation dictates the operation. And the change dictates the operation, not trick words. We'll be chasing our tails about trick words all the time. This is the situation where our change takes us from the finish back to the start. So I have to subtract that change time. Again, very important to have that kind of conversation with students as it relates to the situation and the three positions we're solving for. Finally, it's their turn. Now, I like to do a little bit more of an open problem here, and this was pretty successful. It had the kids kind of thinking. You give them a start number here. They have to be, they give them a finish number here. You have to be at school at 8:50. How long does it take you to get ready for school when you wake up? So now their change time is going to be different depending on the individual. Some kids take 60 minutes, some kids take 20. They get to choose. And then they have to solve for their start time. Like, what time do I need to wake up? So we had a lot of fun with this. Lots of kids telling us different times it takes them to wake up. They talk about, oh yeah, well, do you play some video games while you're waiting for the bus? Or do you, how long does it take you to eat breakfast? How long does it take you to brush your teeth and drive to school? All those things are kind of put together. But again, those are real world problems based on this type of situation with elapsed time. So Math Nights, to summarize it all, we have gone through our approach to a time elapsed problem. Our approach to the time elapsed problem is about the situation where we're adding to or taking away. There are three positions in this type of problem. There's a start time, there's a change time, and there's a finish time. Once we analyze the problem, the students analyze the problem, and they know what position the unknown number's in, they can now work procedurally through that number line, adding and subtracting depending on the change number, and adding and subtracting whether or not they're starting at the finish and working their way back, or starting at the start and moving their way forward. And that's how the situation and the change number help them to dictate what operation they're going to use. There is a template on this lesson on side B on our Math Nights choice board. If you're watching this on YouTube, then you might want to take a look at the description below for the link for the forced copy to this Jamboard. Take care, Math Nights.